So what we have here is the example configuration of ISIS. You can see there is no process ID used. It's not mandatory. In OSPF, we have to specify some number. Here, if you're running only one ISIS, you don't need to really mention a process ID. And the process ID, if you want to mention, it need not be a number. It can be alphabet with numbers or only words, only numbers. It's up to you. We have done those things in the lab, and this is not any new thing for us. And we also know how globally we can make the router to be L1 only. By default, it is both L1 and L2, but in some cases, we say L1 only because there is no connection to any other area from the router. So to reduce the process utilization, we can specify L1 only. And if you will have a router, and if that router is no way connected to any internal router with ISIS, then you can configure it as L2 only because it's going to talk only to other areas. This is globally you enable. And when you globally enable, it's going to be the configuration for all interfaces of that router. Now, if you will say globally L2, and on an interface, if you'll say L1, it is going to be L1 on the interface. On the other interfaces, it's going to be the global configuration mode. Whereas in this interface, whatever you have configured on that interface is what applicable. ISIS circuit type, and then you say what level that circuit should work, that link should work. Here the circuit means the link type. Now the metric, I told you the default metric on the interface is 10. It can be any interface, fast Ethernet, gig Ethernet, 10 gig Ethernet, anything. The default metric is 10 only. You can change the metric value from 1 to 63. You know why? Why it is only 1 to 63? We learned in the previous class there's only 6-bit. Yes, you remember or not?
Yes.
How many bit is for the total metric? For one link, for one interface, it is 6-bit. For one path between source to the destination, how many bits? See, there are many routers. Now, if you want to go from A to B, to calculate the total cost, 10 plus 10 plus 10 plus 10 plus, like that, what is the maximum a path can have? How many bits for a path, for end to end? You see, 6-bit is for the interface. That's why the maximum is 63. And what is the default? 10. 10 is the default. You can go up to 64. And that's what this page says, you see? 1 to 63. Because on the interface only 6-bit is given for metric. But overall path metric is 32-bit. 24-bit, see, on Cisco iOS software release 12, the wide metric, if you say wide metric, allows 24-bit interface and 32-bit path metric. Look at this. This is what I was telling you, 10. The default is the narrow metric. For the total cost, there is only 10-bit. So 2 to the power of 10 is what? Is it 1024? Yes. 1024. That's the total cost. Like you have 20 here, you can have only maximum of 1024 by default between a source and a destination. Between R1 and R3, it should not be more than 1024. But if you make it as a wide metric, if we change it as a wide metric, what is the command? Under router ISIS, you need to say ISIS metric type wide. That's all. You understand? Very simple command. Under router ISIS, you go inside router ISIS and say metric type wide. When you say that, what happens is every interface gets 24-bit for the cost calculation on the interface and 32-bit for the total path cost. It's a big number. We saw that in the previous class. Anyhow, let's come back here. This is the command to set metric on the interface. The default is 10. If you wish to change this 5, you need to say that on the interface ISIS metric. What is this metric? This is the number. ISIS metric 40. ISIS metric 5. Something like that. This is all option 1. Forget about the next. Metric default value. The default value is 10, but if you want to set something else as default value, you can use this metric default value command under the router mode. All right, so here is a sample configuration. Tuning ISIS configuration. You see this router R1 is only L1. See, this is globally defined as L1. This is not needed. Not needed. Waste. When globally it is already L1, you don't need to do it on the interface. So there is no problem in this, according to my understanding. You have done the lab, so this won't be a difficult task for you. Let's go to the second router. Second router is F00L1. I appreciate. Yeah, this is needed. Serial is L2 only. And you see the metric they are setting. ISIS metric 35. Because you are running only L2, you need to say L2 only. Okay. Because the interface is a man-facing interface. It faces the other autonomous system, other area. Now, if you want to summarize, same like what we used to do in ERGRP. Summary address or OSPF NBMA summarization. You remember OSPF NBMA summarization. You say summary address and you mention how you want to summarize, and you need to say for which level you are doing the summarization. If you say, I don't know the exact level, it may be level 1 or 2, then you need to say this. Or if you will say L1 only, L2 only, you need to be precise. If you are not sure, you can say both. The default is only L2, very important, very, very important. Don't imagine, if you don't say anything, don't imagine it's going to be for L1 and L2. No, it's only for L2. Because we do summarization mostly on the border. When you do summarization, you will be summarizing for the other area. That is why the default is L2. Now, show IP protocol. This command should show you this output. We tried showing. I was trying to show you this in the previous class, but it was not complete, so it didn't come. Later, I thought of showing you, but somehow I forgot. But you might have seen when you did the lab. You might have seen the show IP protocol. If not, when you do another lab tomorrow or today, do this command, do the show command and see. So 115 is the administrative distance. Show IP route ISIS, you know about this. We have seen this in the previous class. L1 routes and L2. Yeah, correct. Every vendor will have their own administrative distance. Administrative distance is Cisco specific. It's not global. It's vendor specific. It is not global. Yeah. So these things are good for. Okay, please take a snapshot of this page. This may be useful for you when you do lab next time. Yeah, yeah, it is. Here is another command. There are a few more show commands for troubleshooting. Show ISIS routes. It will show you the routes that are learned through ISIS. It show ISIS. See, we type show IP route. This is different command. This is show IP route ISIS. Whereas this one is show ISIS route. Displays ISIS level 1 routing table with the system IDs. Now, these are all interesting commands you should try seeing instead of me telling something. Better you see it. You'll get it. Inter area, you might yourself already did a nice lab. So you might have seen all these commands show IPI, show ISIS topology. You will see both L1 and L2. If there is an L1 router, like router 1, you see only L1 topology, L1 database. If it is L1, L2, like a border router, then you will see two database, one for L1 and for L2. This is a nice command. We type show IP protocol, like we show CLNS protocol. Will show you almost a similar output like what you saw in show IP protocol. But here the good new thing is you got system ID displayed separately. It takes out the system ID separate, area ID separate, and it shows what all interfaces runs ISIS. Yes, please. I got you. I got you. This one now, when you type this command, you get that right. Okay. So, yeah, I was telling you the other day, ISIS is not designed after OSI. It was before OSI. So, depending on the module, depending on the vendor, the output may vary. So, I'm sorry you got some other unexpected output. Maybe in the newer version of operating system, this command is no more available. Did you try with the area tag, area ID? Show ISIS 0000 route if you are in area 0. Okay, Fine. Later, when I do the lab, I'll do this command and I'll give you more inputs on this. And show CLNS interface. I remember I was showing you this command right from the beginning. Show CLNS neighbor. Right. So this was about the lab that you already finished. So let us go back to our previous chapter, chapter number 2, where we have left something. We need to continue that. So we did a nice lab, somewhat similar to this with multiple areas. Now let's move further in the second chapter. Here, what it shows here is the system ID is in black and the end selector is in blue, and system ID is always 6 byte. It cannot be more than this, it cannot be less than this. System ID is used in L1 routing and has to be unique within an area. So system ID need to be unique within an area. Please tell me, will the system ID be matched in L2? L2 only looks for area ID. Isn't it? What is L2? Talking to other area, no? So system ID is used to identify device within L1. So every device need to have a unique system ID in L1. System ID has to be unique within L2 routers that forms routing domain. The consecutive router should be the consecutive routers should be unique. See, if you are having L2 continuously 4 L2 routers, definitely system ID should be unique because they form a group. General recommendation: use the domain-wide unique system ID. This may be means what does this mean? Take your MAC address and add some value in the middle, or take an IP address, see 192.168.0.1. Take your IP address or MAC address, add some number values, numerical values, make it unique. So when you take an IP address and use it as a system ID, there will not be a problem at all, isn't it? MAC addresses are unique. Yeah, that's what they mean. So the end selector field will be always 00. That is for IP. There is nothing here, so it should be always 00. SNPA is equivalent to layer 2 address. What is SNPA? Subnetwork point of attachment. Which is nothing but the MAC address. Interfaces uniquely identified by the circuit ID. Yeah. No. No. Fabric path uses fabric ID. Actually, it is the same thing. Instead of saying system ID, we say fabric ID. Okay, here, interface is uniquely identified by circuit ID. On the point-to-point interface, MAC address is used as the circuit ID. That is what called as SNPA. On a LAN interface, circuit ID concatenated with 6 octet system ID of a DIS router, designated router. I was telling you the other day, when you type show ISIS neighbor, you will see circuit ID there. And that circuit ID will be the ID of the router whose MAC address is bigger. Did I say you that? Between R1 and R3, which one will be having the circuit ID? Whose circuit ID will be seen in R1 and R3? R1 will have R3's ID. R3 will have its own because R3 has got the bigger MAC address. So R3 is the designated router. In OSPF, priority. 64 is the default priority. You can increase. Now, Cisco router use the host name instead of a system ID. There we saw that one, R1.01. Now, L1, L2, L1 and L2. What does it mean? L1 means it's an internal non-backbone router. L1, L2 is equal to ABR. L2 is equal to backbone router. Do you agree? Area address is used to route between areas, not the system ID. Whereas system ID is used to route within an area, not the area ID. You agree? Well understood, right? Please go through this. It's easy for you. So I repeat, if the destination that you want to go, if it is in same area, then it will use the system ID and see where the destination is in the database and delivers the packet. If the destination is not in the same area, then it will use the area ID and deliver the packet to the other area using the L2 database. That's the total meaning of this. All right, something like this you have already done. Now, I want you to answer this question. Take 2 minutes. Think. Which path or what path would X use to reach Y? And what path Y will use to reach X? You will use the green path for both up and down. Okay, so your answer to the path from Y to X is a green or yellow? Which one? Okay, which means you need to understand the previous page more closer. You need to go through this page again. It's exactly the same thing explained in that question. If you understand this, you will answer this. Or if you understand that, you will answer this. You will understand this. Wonderful. See, you're right now. Okay. You see, optionally, you can leak roots from L2 to L1. We saw by default. Yeah, kind of. You see, when you have L1 only, you did one lab, right? You did a lab. I think this was the topology. Oh, the topology is not with me here. Here, you see, in this picture, this router is L1 only, right? Now, will I have a default route here or a precise route for reaching other area? I got default route. But for some reason, I want one particular network, say for example, from here 3.3.3.3 is coming. I want that router, only that network. I don't want this 2222. I don't want this 4444. On this routing table, I just want this network, which is in another area. It's a L1 router, but I want to have L2 routes. You understand? Which means in this router, I need to leak some L2 route to L1, isn't it? Which route? 3.3.3.3, which is an L2 database route. I leak it to L1 database so that it will come here. That is what we call it as route leaking. Helps to reduce suboptimal routing by allowing L2 information to be leaked into L1. For that, what it will do is it will use additional fields called type length value. Type length value, don't get confused with this. This is nothing but field. It's an additional field, extra bits. This is no more ruled out. End system and all, there is no, you don't need to know this one. You have only this one. This is how the ISIS is identified. And this is the first byte of all ISIS header 83. Not that important, but I'm just giving you an information. See, when you capture a Wireshark frame, in frame you will see data link PDU frame. Frame value will be this one, 0xFE. The Wireshark, you can see that. What is PDU? PDU is nothing but TLV is nothing but packet length value. PDU is nothing but protocol data unit. Okay, protocol data unit. It is nothing but packet. IS5 packets are encapsulated directly into data link frame. There is no CLNP, there is no IP header in the packet data unit. ISIS PDUs are means, I said PDU means what? No. The other word for PDU is what? Packets. ISI's packet types are as follows. Hello packet. Hello packet is called as IIH. I told you what is IIH. You remember? Intermediate system to intermediate system. Hello. Intermediate system to intermediate system. Hello. IIH. In OSPF we say OSPF hello because we don't call router as intermediate system there. But here you call router as intermediate, so you don't simply say hello, you say IIH. This is same story. Label switch path. Sorry. Link state link state PDUs. Link state packet. You also have partial sequence number PDU, complete sequence number PDU. What is this? If you are sending the complete database, it will be CSNP. CSNP is equal to DBD in OSPF. You remember DBD, database description? PSNP is equivalent to LSR and LSU. Link state request and link state LSU update. Link state request and link state update. It's equal to LSU. This is equal to LSU. Not complete. Only the query is been answered. Partial. The headers and all not necessary because we don't really have this end system and all. Just skip these things. These are all not going to help you. Here also it uses sequence number. When new update comes, it increases the sequence number. Yes, please. Question, please. Yeah, we'll do. We'll do today. Let me finish this. Label switch path header. LSPs are sequenced to prevent duplicates of LSPs. Label switch protocol data unit. Assists with synchronization. Sequence number begins at 1. Sequence numbers are increased to include the newest LSPs. It is the same like OSPF. LSP in LSDB have remaining lifetime allows synchronization. It's actually decrementing time. So when it becomes 0, it will time out. It will expire. The update will expire. But updates are coming every now and then, so it won't expire. These are all really not needed. Don't spend time on this. It supports broadcast. It supports point to point. In broadcast, you will have designated router, same like your OSPF. See, there is no concept called NBMA in ISS. In OSPF, we had NBMA. You remember NBMA types? Implementing network types in NBMA and implementing ISS in NBMA, which we are not, we will never do it. We need to specify the keyword broadcast. That's all. It will work. We are not going to do this lab because it's not really useful. You know what is broadcast mode? There will be a designated router. Like our broadcast environment in OSPF. In OSPF, if you have more than one neighbor, you will have a designated router elected, right? DR. But in ISS, the difference is there is no backup designated router. Designated routers are here called as this. What is intermediate system? See, what is DR? Designated router. But we don't use the word router, no? In ISS, we use the word what? Yes, that's why it is this. You understand why they called us this? So this is elected based on the priority first. If the priority is a tie, then it's going to compare the MAC address, very important, not the IP address. OSPF compares the router ID, isn't it? OSPF compares the router ID. This is what the disk router. If you have 4 router, one router will be elected as a red disk. Why they are drawing like this? They're trying to show that it is floating, means at any time it will move from here to here. If this fails, it will move here. If this comes back, it will come back here. So OSPF it is non-preemptive. Here it is preemptive. This is preemptive here. All right. I think we need to stop here. We'll talk about these things later.